Welcome. In this screencast, I want to explain the term run to completion. Let's have a look at the classical object paradigm. The key idea is that object attributes are encapsulated and cannot be accessed directly only by method calls. Method calls can change the internal object state. When we follow a thread of control, usually in an operating system thread, at some point we will call a method of our object. The method implementation, for example, modifies a first attribute and a second attribute. And finally, the thread of control returns from the method. So far, everything is fine. But things get more complicated in a multi-threaded environment. Here, the execution switches between threads on a fine-grained base. So now let's assume we have two threads of control. The second thread also manipulates the object's attributes, which might lead to collisions due to an inconsistent internal state of the object. Obviously, we have a problem here. One solution could be to use OS synchronization mechanisms like mutex and semaphore. But this not only is tedious to implement, but also is prone to deadlock situations. Another possibility, and this is how eTrice resolved the problem, is to decouple objects by the execution model. We speak of run-to-completion semantics of the execution model. What does that mean? This means that from a logical point of view, every actor acts independently. They can be regarded as isolated logical machines. This is achieved by message passing between actors. Each actor has its own event queue. When it is active, like actor 3 in our example, it grabs the next event from the bottom of the queue, processes it, and as a result sends two messages to its peers. When the message arrives, it is turned into an event which is placed on the top of the queue. Now actor 1 gets active, processes the next event, and as a result sends a message to actor 2, and so on. To summarize, in eTrice room systems, actors are decoupled by usage of asynchronous communication and event queues. This way, an actor can never be in an inconsistent state when it is processing an event. Thank you for watching this video.